all the NumPy functions, NumPy universal functions will work in pandas data frame, right? So if you have a pandas data frame like this, and if you have numerical columns, then you can apply, like ABS or exponential or mod or square root or power, and all of those functions will work. Now we can also define our own functions. Okay, so if you have a particular type of computation that you need to perform on columns that are specific to your domain area, and it's not in the NumPy, then we can define a function. And when you define a function, your own function, then you have to use the apply function, apply method. Okay, the apply method will take the function that you give within the parenthesis and apply it to all the columns of the data frame. So apply is element-wise application. So this function will be applied to each element of the column. Okay, and x is equal to 0 is the default. Okay, so if you leave it, then it will go to all the rows within a column. Okay, so you'll get one result for each column. So here I have a lambda function. Okay, lambda function is just a one-line function. It's easier. So here, say we want to find the range of values in a column. Range is the largest value minus the smallest value. That's your range, right? So I've defined a lambda function. Okay, so lambda function, we looked at it a long time back. So I've given a name for that lambda function. So I have lambda x. Now what is that x? Okay, so you're going to supply the x. Okay, so that's going to, when you run f range, x will come in. Okay, so that's what the input goes in here, the input. So input dot max minus input dot min will give you the range. Okay, so that's defined there. So now if you apply that function to DF7, then each column of DF7 will be sent to f range. So each column will go first time, the first column will go here, and then it will find the range. Then second column, then the third column. So that's how you get these three numbers. Okay. Well, I have to run all these cells above, run all above so that everything is available to us. Okay. Okay, so now we can run that one. So DF7 has three columns, V1, V2, and V3. Okay, so that's applied. Now we can, if you don't specify axis, then axis equal to 0 is default, which means it's going to go, each row, you'll consider all the rows within a given column. So that's your first dimension. Now axis equal to columns, we'll do it the other way around. It's the same function. Now this time, each row will be sent to the function f range. Okay, each row will be sent to the function, so x will be each range, each row, and then it will find the maximum minus minimum. Okay, so axis equal to columns, axis equal to rows. Okay, axis equal to columns is axis equal to 1. It's the same as axis equal to 1. Axis equal to 0 is axis equal to rows, and that's our default. Okay. Now here is another example. Here we have, we can return. So right now in the first example, what we get back are just simply the numbers, right? So V1 is 3, so we can look at what is the type. So if you put type around it, it will give you, so it is a series, okay, and we can specify explicitly a series here, okay, and there is a reason for that. I'll explain that in just a second. So suppose if we define a regular function, or this is not a lambda function, okay. You could set it up as a lambda function because it is simply getting the minimum value. So this is another way of setting up the function. Instead of lambda function, I have a regular function. So regular function is defined with the DEF, the name of the function, and an input. Okay. Now we are returning not just the x dot min, but we are converting it into a series. So PD series, then we can give a name to that whatever that we are returning. Okay. So now if you apply this function fmin to df7, okay, and then if you print the type, it tells you that it is a data frame, okay, and here is what you get. So when you send back a series, then it will automatically convert it into a data frame. Now what the advantage of this is that you can send several results, not just one set of results, and they will all be assembled into a data frame. So here in this example we looked at only the min, right? Now let's say that we want to return both min and max. So this example we have the same as before. So PD series, now we have x dot min and x dot max as a list. And then I'm giving an index of min and max. So when you run this and apply it, okay, we use the keyword apply. Okay, so then the index is used here, min and max, and then columns, and you get a data frame. So if you change this to axis 1 and you apply the same function, f min max and axis equal to 1, each row will be sent in and you get a min and a max for each row. Okay. All right, so let's look at your turn here. So we want to create a function that will return a pandas series, okay, so that the assembled values will be a data frame, sum and sample standard deviation. So create a function that will return a pandas series of sum, okay, and sample standard deviation back. And then we want to apply that function to age and weight column of DFQ 17C. Okay. So if we are returning just one value back, we can do a lambda function. Now we are returning two values, sum and standard deviation. So we have to set this up as a regular function. Let's call it, okay, give a name. Actually start with DEF, give a name. So let's say, okay, f sum std and say x. So whatever x is, okay, x is a collection of elements. Okay, that's going to come into the function. Now we're going to perform some operation and send the result back. Okay. So I'm going to do it in just one line of code. So we can set it up separately, find the sum, find the standard deviation, and then put them into a series, or we can do it this way too. So this will be just a very simple function. So what I'm going to return is PD series, okay, of what? So we're going to return two things. So we have to specify this in a list. So x is what is coming in. So we want to sum the values of x. Okay, so that's one set. And then we want std x dot std. Now this is a pandas standard deviation, so this is going to be a sample standard deviation. Okay. Now if you want to be pretty sure, so the default is dd of what equal to 1. Only in NumPy the default dd of is 0. So but to be sure we can put dd of equal to 1. Okay, so that's the list that will be returned, and we can send an index for that data frame, and so that will be sum and standard deviation. Okay. Okay, so now we have defined the function. Okay, now if you want to apply this function, so that's our A. Right? So the input is x. Okay, x can be anything. Okay, it's going to, whatever x that you send to this function, it's going to do the x sum and x standard deviation and return it as a pandas series. So now you will have, each of them will be a pandas series, so it will be assembled as a data frame. Okay. So do you have the function defined? Have it ready? Okay. So now we're going to apply that function. So dfq17c. So that's okay. So now that's the data frame that we've been working on as in our your turn section. So that has these are the variables. Date of birth is in date time, name and smoke or status or object. And then we have weight and age are the numeric variables. So here we have to specify age. You know, if you apply this, if you apply some std, okay, it's going to send all the columns, okay, and we are not checking. So here we could check, you know, so the column coming in, is it a numeric column? If it is numeric column, then do the computation and return. If it is not a numeric column, then return nothing, and that way we can suppress this error. Okay. But we are not doing that. We just assuming that whatever is going to come in is going to be a proper numeric column with which these computations can be done. So now we have to take the precaution and send in only the numeric columns. Okay. Now if you say age here, okay, again it's not working because we have to give this as a list. Okay. So we have to give the columns that we wanted to be applied to as a list. So this is the first square bracket is to access the columns and what's inside the columns must be a list even if it is one column. So that's the second square bracket. We want both age and weight weight W is uppercase. Okay. So now this applies this function to each column provided in the list. Okay, only what's in the list. So you're making sure that what you're sending in to the function are numeric columns, so you don't get an error. Now you can round this if you like. I wonder whether